kind of want to walk in like Lucky. That man is smooth. So, hi, my name is Sheena. These are my emojis. I've been coding for a long time. I started as a teenager. I've mostly worked in weird startups. So I enjoy organizations where there are a lot of different hats to wear and a lot of different unexpected problems. Most recently, I've been working as a CTO of Umuzi. So I'm sure like some of you have heard about it, some of you haven't. Basically, it's an organization that's involved in education. So a lot of different types of training. I've trained a bunch of people for BBD, and their freakishly high standards helped make me better. Thank you, BBD. So what did I do there? As a CTO, the way I thought about my job is I'd take the science of learning and turn it into the engineering of learning. So that meant things like staying on top of like social sciences and how the brain works in different ways, but also, of course, like actually building stuff. So I built stuff, and I dealt with human processes as well, because the stuff and the people had to mesh and work together nicely. So the astute among you may have noticed that I was talking a little bit in the past tense there. I'm no longer the CTO of Umuzi, so this is my first week of being unemployed. Woo! So what am I doing now? So I'm still in tech education. I am working towards building tools and systems that help tech educators with their trickiest problems, because I have solved many of those. So onwards to glory. We're here to talk about web testing. And before I talk about testing, I want to show you what we're testing. So I'm going to start off with a demo. All right. I'm going to show you the demo, which is over here on this tab. Okay, so I've got a to-do list app. Because it's relatable, we all have stuff to do. And do I have it running, actually? No, I don't actually have it running. All right, so I'm going to run this thing. Python. All right. Does anybody know what framework I'm using here? Hell yeah, Django. All right. So I'm running a Django app. Django is known for its front-end prowess, right? No, it's not. So this is a Django app, and it looks reasonably good. I can tick some boxes. There's these modals that come up. I can delete some things. There's more modals, and I can add stuff. Right. It looks and it feels a lot like a single-page application, but it's not a single-page application. So if I open up the dev tools here and zoom in aggressively, I think that's probably enough, and I add something here, then you'll see that there is a request that goes off to the back end. This is good. Now, if you're used to front-end web development, you'll think like, okay, the request goes back, comes back with some JSON, and then we interpret that and put it on the DOM somehow. That's not what's happening. So if I click here and I look at the response is HTML, and the response looks like this. So what we're doing is we're actually taking that response HTML and putting it at the end of the to-do list over here. So we're appending it to the end of this div. And the same kind of thing happens with the delete button. So item deleted successfully. If I look at that, item deleted successfully. The contents of the modal are coming back, and I'm putting that in somewhere on the screen. Same deal with the tick box. When I check something or uncheck something, it looks like that. So this isn't a single-page app. Every single one of those HTML responses is a little Django view, and we're server-side rendering everything. So that's pretty nice. It's a nice way of building modern front ends with Django. So what's in the box is Django. That's the first thing. So for those of you who have not used Django before, it's not the newest kid on the block. It's been around for a while, but it's freaking rock solid. I like it a lot. Its catchphrase is that it is the framework for perfectionists with deadlines. Like me, maybe like some of you. It is rock solid. And one of the things people say to me often is like, but does it scale? The appropriate answer is Instagram, or Reddit, or YouTube. So yes, it scales very well. Scalability often is to do with the infrastructure. But one of the things that is great about Django and Scale is the fact that it makes your team quite scalable. So it's also backed by a fantastic open source community. They're like really wonderful, warm people, and it's built around an ORM. So I know lots of people don't like ORMs for different reasons. They're not the fastest things around, but it's a tool that can be used well or used badly. Django uses it especially well. So for those of you who don't know what an ORM is, It's an object relational mapper. Basically what that does is it adds a layer between your, well, it allows you to interact with your database in a nice and convenient way. It allows you to create classes, and each class represents a table, and each row of the table can be represented by an object of that class. And so you can interact with your database in a Codey way, in this case in a Pythonic way. So that's quite nice because the ORM then exposes a really consistent interface, which makes it easy to develop things on top of it. So that's Django. Django's great, you should try it. The next thing is HTMX. So HTMX is the thing that did that magic where the HTML elements ended up being appended in different places. So if you look at the code, if we look at, not the code, this, if we look at, I'm just going to add something here. All right, so I'm adding something here, and if you look at the response, there's all sorts of weird things going on, like, oh man, where is it? There we go. So like hx put and hx target and hx swap and stuff like that. So this is the unusual thing. Like HTMX adds extra attributes to your HTML. So HTMX has a catchphrase too. It's a bit longer than the Django catchphrase, so I'm not going to read it all. But it gives you access to Ajax, CSS transitions, WebSockets, server-sent events directly in HTML. This is all things that you'd want to use in a modern website. So the way that I think about HTMX is that, like, if we were to look at modern web development and say, okay, how could we make HTML better so that it could do modern web development? What would we change? We'd do this. We'd make something like HTMX. HTMX will probably die when HTML gets upgraded, because this is how it kind of should be. So this is the hello world of HTMX. We have a button, and when we click the button, we do a post to this endpoint. This endpoint will respond with some HTML, and then we swap this entire button with the HTML that gets returned. So that's one use case. This is using a whole lot of the default behaviors. So by default, HTMX will be tied to the click event of a button because it's a button, but you can tie it to different events. You can say like on show, or like on scroll, on render, all sorts of things. So, and you can also target different elements in the web page. So by default, the originator of the event is the thing that gets targeted. So it'll be like change like swap out the HTML here, this button where the event came from. But you can also say put the HTML over there, which is what we did. So this is the actual code that we were running in the form. So this is a simplified version of it, but basically we've got a form. The default event that we're tied to is on submit, and when we submit the form, we do an hx post to this endpoint over here, which returns some HTML. Then we target the to-do items element on the page, and then we take the new HTML and we put it before the end. And that's all it really takes to make this form update the front end. Like, that's how complicated the code is. So I really, really like HTMX. It can't do everything, but it can do a lot. So we're also using a little bit of Alpine. So Alpine is also something that adds a little bit of extra spice to HTML. So this is the hello world of Alpine. Here we're defining a variable false, open, and initializing it to false. And it is defined within the scope of this div. Then when we click this button, we change false to true. We change open to true. And when open is true, we show this thing. And so that's itself quite a versatile thing. So that's how we handled the modals at the top. Alpine does a lot more than this, and it is worth checking out. Last but not least is Tailwind. I think everybody here probably knows a little bit about Tailwind. It is a nice way of managing your CSS classes so that you don't need to have crazy, hard to understand CSS files. Like, you do this kind of thing instead, and it's pretty easy to read and understand, which is great. Now, to be clear, like, whenever I do this talk, people are like, is that a Django thing? Like, no, HTMX is a web thing. It's like a tiny little library that you just like make a little script tag in your HTML and then it works. It works on old browsers, it works on new browsers, it works on like very terrible machines, so that's great. None of these tools are specific to Python, none of them are specific to Django, they're just web things. But they're very, very popular in Django land. So I'll share a link to these slides a little bit later. It's got a few references to different talks done by people like this guy. So if you want to see somebody really make HTMX dance, watch this talk. It's incredible. Then, so I'm getting to the testing, I promise you. Like, most of this is a preamble. All right, so we now have a different way of building full stack applications in tools like Django. So before HTMX, you'd do this kind of thing. We'd have a Python backend, and then you'd have some kind of fancy front end, and they'd need to talk. So this is a stack that I've used before. On the backend, I had Django, then I had Django REST framework to expose some APIs, and then Guardian to protect those. And then on my fancy front end, that was React, and then I went to the component library, Material UI. You need to manage some states. You have Redux, and the side effects, so the sagas, and it's complicated. Like, to make a single full stack feature, you need to know all that stuff, and it takes a long time to code. Compare that to a stack that relies on HTMX for the front end. It looks a lot more like this, which is nice and simple. Now, with something like this, if we wanted to test out the front end and make some like full stack tests, then you would think front-end thoughts. You'd be like, okay, what in the React ecosystem can I use to test my code? Now it's like, how can we test it in a Pythonic way? And that is where Playwright comes in. All right, so now I'm going to show you some testing. Are you ready? So standard unit testing is insufficient, of course, because a lot of our interactivity is defined in the HTML. Unit testing is still very, very important. I was having a chat to someone earlier about Playwright and how it makes tests slow. There's a test pyramid. You want to write some end-to-end tests and then like much more unit tests. So you need both, but Playwright serves a specific purpose. So Playwright, this is its catchphrase. It enables end-to-end testing for modern web apps. Practically speaking, what it does is it fires up a browser and it lets you interact with that browser. So it sounds a lot like Selenium and a million other tools. What's special about it is that it's got all these extra useful test goodies built in. So it has like expectations and traces, and you can get it to take a video of things when it failed and all sorts of cool fancy stuff like that. And of course, because it's a web automation tool, it has uses way beyond testing. So I first heard about Playwright, or got excited about Playwright, because of watching this talk. So this is, again, it's a Python talk, but it compares Playwright to a bunch of different tools in that ecosystem, and it pretty much convinced me that it's a good choice. So if you want to see how it relates to other things, go check that out. Highly recommend. All right, so now demo time. All right, so the moment you have all been waiting for. We're going to run some tests. All right, and well, hey, the end. Do we have any questions? All right, so I'm going to show you a little bit of how to make Playwright dance. So there is quite a lot going on here, but I'm not going to go through all of it. I'm going to make it bigger because I'd like you to see. All right, so I'm just going to show you one test, because that one test kind of demonstrates everything. So the first thing to notice here is that I'm using this thing called PyTest. Django typically doesn't come with PyTest. You have to install it after the fact. I wanted to go with vanilla Django as much as possible and just demonstrate these front-end cool things. But Playwright plugs into PyTest really well. It's got all sorts of tools that are built in there. So if you want to use a different testing framework, you're going to have to do a bit more work. And PyTest is lovely. There's like basically no boilerplate. So we are using PyTest. So this first test here, test display empty list on first load. This basically tests that when we come here for the first time, and this is empty, it should say that there's nothing to see. So that's what that test is about. PyTest, how it works is it allows dependency injection. So these things here in the function call, in the function prototype, these things are called fixtures. And when this test function gets called, then PyTest will instantiate those fixtures and pass them in. So the first fixture is a thing called live server. So basically what that does is it spins up a server so that you can interact with it. And then the next thing is page. So page comes from Playwright, and how that works is basically Playwright will open up a browser, and then it'll give you access to the first, like a tab in that browser, and then you can interact with that. So I'm actually going to kill this just to prove a point. So now our, this is broken. See, I turned it off. So we don't need it to be running. Ooh, damn, I didn't mean to do that. Oh, okay, it's okay. Oops. Lol. All right, cool. We don't actually need it to be running. Oh, crap, I think I killed StreamYard. Give me just one moment. Sorry. It's all good. Oh, Chrome. No, I was just tight screen. Yeah. Cool. Yeah. Yeah, it should be good. Sweet. All right, cool. So as you can see, our server is no longer running, but our tests can still run. So if I go back here and I say PyTest again, then the test will still run and pass because we're not, like, we don't actually need the server to be running. So if I go back to, okay, there. All right, cool. So what's happening here in this test is the first thing we're doing is we're getting the URL of the page that we want to test. So we always dynamically fetch the URL. We don't hard code the stuff, and there's a bunch of different reasons for that. One of the reasons is because we don't know what the URL will be. So I'm just going to put in a breakpoint here. I like Python debugging because it works everywhere. And I'm going to run the tests again. I'm going to make that bigger. Make it really huge. All right, so if I check where we are in the code, we're over there, and if I look at the URL, it's like localhost 43801. So there's no way we could know that ahead of time, so it's important to derive your URL. Cool. Now, the next thing that we do is we go to that URL, which isn't that complicated, like that's a normal thing to do, and then we wait for selector. So waiting for selector is interesting in a bunch of different ways. So the first thing to know is that there is a selector. So right now it says that there's nothing to see here. Or we were waiting for the text to say nothing to see. There's lots of different ways that you can select things. So here we're looking for text again. In this test, we're saying like look for the input that's name is title and then type some stuff over there. We can also click on buttons. On this line over here, we're clicking on a button. So it's like pretty versatile in that way, but you'd expect to be able to do that. The other thing that's quite cool about this line is it says wait for selector, wait specifically. So that's quite nice because we're dealing with a front end that is asynchronous. When you're testing or interacting with a web app, then asynchronous things happen. So often you'll visit a URL and then you'll wait a little while for a thing to load, or you'll click on a button and you'll wait a little while for the next thing to happen. And so if you're not using something like Playwright, like if you're just using raw Selenium, then you'll have to have some kind of waiting function built in. So if this didn't have a way of like waiting for you, I'd have to say like time.sleep, maybe how long should it take? Should it take 100 milliseconds? Let's make it 200 just to be safe. And that's the kind of logic that you need to go through to get your stuff to run, or similar logic to that. And you end up having these explicit waits that make your code messy and hard to read. It's like it obscures your logic, but it also makes your tests run slower than they need to. Because if I'm testing it on my like monster machine and somebody else on my team doesn't have as good a computer, then they just like double all of the delays, and now it's slow on my machine, and it's terrible. So having this, having Playwright do the waiting for you is very, very helpful. Under the hood, it's just a loop, and there is a timeout, so it won't wait forever. Now, running the tests and just putting it in, like, just running the tests is pretty boring. Playwright is wonderful because it has all these sensible defaults built in, and we are going to now start playing with those values and changing how it works. So by default, Playwright runs in headless mode. So what that means is that the browser is hidden. I can do it in headed mode by using the helpful flag headed. And now we can see exactly what's going on. Hold on. So that was great, but we couldn't see exactly what was going on. So we got this slow-mo as well. And what that does is it slows everything down. So now I'm saying, wait 2 seconds in between every interaction. And now we can actually see our test run and we can watch what's happening. So here we're adding an item onto the to-do list and it works. And there, oh yeah, there's a fourth test now. That fourth test. Cool. All right, sweet. Actually going to get rid of that fourth test because it's making things slow. Actually going to get rid of it completely. All right, so that was nice and all, but you might have noticed that we're testing against one browser. We're testing against Chromium. You can also test against Firefox. So you can use this little browser flag over there and say Firefox, and now we're testing it against a different browser, which is very, very helpful because lots of browsers exist in the world. All right. If you wanted to, you could test against multiple browsers at the same time. So you can say test against Firefox and then test it against Chromium because you care about both of these things. So now you'll see that there were 3 tests. And now there's 6 tests. So it takes a little bit of time to spin up the second browser, but it passes in all of the things. So that is very, very handy. Then the next thing that I want to show you is a thing called tracing. So tracing is really, really helpful because sometimes things go wrong in your tests. Sometimes you'll run your test and it'll be like something went haywire in Chromium. Let's take a look at that thing specifically. So when I use tracing on, then if I press Control B, I go to the files. When I turn tracing on, then what happens is it creates these trace files. So there's this thing called test results, this directory that it creates. And within there, we've got a whole lot of different directories. And each of those has a zip file in, which is a horrible, horrible zip file that you don't want to interact with directly. But in order to interact with it, what you can do is you can use the show trace command. So how that works, as I say, Playwright, show trace, and then I give it the full path to the thing that I want to look at. So that's like test results, to do, test, blah, 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 add new item, Chromium. So you'll notice as well over here that we have a bunch of directories. We've got 6 directories here. And we've got one for each test and one for each browser. So you've got like add new item Chromium, and then add new item Firefox, and then display empty list Chromium, display empty list Firefox. So you got one for everything, which might be excessive in some cases, but we've got one for everything. So if I open that up, okay, I'm going to zoom in a whole bunch so you can see. All right, so if I open that up, then I can see the entire timeline of the test and everything that happened, like all of the network requests, where things were clicked, all of that. So here are all the interactions that I had with Playwright. And if I hover over those, I can see where on the timeline they happened, and I can see what the front end looked at, like at each point. Sorry, this is tiny. The only way to like make it small. So now you can see that. So you can see what the thing looks like at every point in time. Whoops. All right. So then I can interact with this to see how things change. I can also take a look at the network calls over time, and I can see how these change and when these happen. So this happened there, and then we called the action to do like right at the end, which is great. I can see that there's a warning over here. So if I click on this, I can go and see the warning. It's like CDN tailwind CSS.com should not be used in production. That is a good thing to know. Don't use it in production, guys. Yeah, so that's very, very helpful. Now, in theory, like storing all the traces all the time probably doesn't make the most sense. If I say pytest and help, then I can see, oh man. Oh man. Oh no, it did work. I'm just being weird myself. All right. So if I scroll up here, then you'll be able to see eventually that there's a whole lot of different things that Playwright can do. So we can turn tracing on, we can turn tracing off. It's off by default. And then we can also just say retain the traces on failure. So the stuff is available during, like, at all points in time, and it's all pretty good and straightforward stuff, which is great. Now, sometimes what you want to do is interact with the browsers while they're running, because sometimes seeing the traces after the fact isn't good enough. Sometimes it's a little confusing and weird. So this is perfectly normal Python PyTest code. And so any debugging that you usually do will work in exactly the same way. So we can, for example, use VS Code to debug stuff. I wish I had a much bigger screen. Let's add a breakpoint over here, just for funsies. All right. And now I'm gonna I need to actually zoom out to be able to see things. Cool. So I'm going to click on the little testing beaker over there, and I'm going to choose to debug. And when I choose to debug stuff with VS Code, then it will run everything with its own idea of what the sensible defaults are. So it'll have headed mode on, and it will also have it'll have headed mode on basically. So it stopped over there, and we can see where we are in the tests, and the browser is also open somewhere. Where is it? It'll be behind this. Things to do. So that's the test that we're busy running right now. So as I move through this, I'm just going to click that a few times, and the test passes. So you can step through your code however you need to. My favorite way of debugging Python code is just with Python breakpoints. So that works the same kind of way, except you do it all in the terminal, and it's highly configurable and lovely, and it works everywhere, and you don't need VS Code to do it. So that works in the usual way, which is great. So that's fantastic. Now, the next thing that I want to show you is quite cool. What I'm going to do is I'm going to introduce a bug into the code. I'm going to, let's see, where is index? All right, so we've got our form and it submits, and I had to do something fancy here in order to make the form clear between submissions. All right, so now let's go back here. I'm going to run my server again and go back here. Cool. So this is running. Now, the bug that I've introduced is this. Let's say we've got like 3 things we want to add to our to-do list. I'm going to add the first one. 1, enter. Now the second one, 2, enter. Oh no, it says 1, 2. So the bug that I've introduced is that the form does not reset after every submission. And that would be an annoying thing. Like, it's just a bad user experience to have to backspace all the time and clear the form. So when there is a bug, it's really nice to solve that bug in a test-driven development way. So the way I'd like to do things is write a test that fails because of the bug, and then make the test pass by making the bug go away, and then you don't get any regressions or anything like that. So we're going to go through that in the Playwright way. So Playwright has this really, really cool thing built in called CodeGen. Now, CodeGen allows you to interact with a website in a way that, like, generates code. That's the name, CodeGen. Where did my mouse go? All right. So I'm going to say Playwright CodeGen, and then you have to give it a URL to point to. So for CodeGen to work, you need to point it at something that's actually live. You can do this to generate code for interacting with a website. Like, I have recently, like, you can do it to build your own APIs for websites that don't have APIs, which is quite helpful. So when you run that, then it opens up the website, and it opens up this little editor over here, and I'm going to make it bigger. And light mode, so it's a bit easier to see. All right, cool. So here we are. And here is our website. Let's put that on that side of the screen. I'm going to favor making that one bigger so that I can show you the code a bit better. All right, sweet. So here we are, and I'm going to click on some stuff. I'm just going to tick that box, and you can see that a line of code appeared over here. It said get by test ID toggle item 317 dot check and dot uncheck. and I can click on this, or I could double click on this just for funsies. So I can do whatever I need to do. In this case, I want to write a test that asserts or expects that this title box will clear in between form submissions. So let's say 1, all right, and I'm going to press enter, and now we can see that it hasn't cleared. Now, Playwright has a bunch of cool little helpers up there that you can play with as well. So I know it's small. This one says pick locator. The second one says assert visibility. Then there's assert text. And then the last one is assert value. So I'm going to assert that the value of this input is a certain thing. So when I click on there, then it says expect page get by label title to have value 1. All right, cool. So that's not really what we want, but it's close enough. We have enough code that we can actually do something useful. So I'm going to copy that code. Everything above those lines, everything below those little lines is a. Where did the mouse go? Everything below these lines here is just a cleanup, so I don't need those. So I'm going to go back up here to my test to-dos, and I'm going to reinstantiate this test over here. So this test says, maybe make it bigger again, and all right. So this test here is about testing that the form clears between submissions, and I'm going to paste in what I took from there. Now we want to use our fixtures. We don't want to use this hard-coded URL. So I'm going to get rid of everything above there, and I'm just going to say page.go to reverse URL live server index. So it's like all the other tests. And then I'm going to get rid of all of that weird stuff as I was messing around. So all of the checking and all of the unchecking and the double clicking and whatnot. Now we fill it with 1, and then we press enter, and then we want the value to be empty. Cool. So now, if I run PyTest now, you'll see that the last test waits a while, keeps waiting, and then it fails. So what we experienced there with the waiting was how it deals with asynchronous stuff again. So it was waiting to check, like, okay, is it empty now? Is it empty now? Maybe there's some background process happening. Oh, no, it's taking too long. So that's why there was that delay there. So now we can go and make our test pass by undoing what I did there. So I'm just going to put that line back in. So that's an HTMX thing again. You can just you can tie into events in different ways. So here I'm just saying after the request was done, then reset the form. And now I can run the test again, and they'll all pass. All right. So that's a whirlwind tour of Playwright. And Playwright's pretty simple. That's most of what it does. So if I type in PyTest help again, then this actually forms as a nice summary of what we went through in this session. So, all right, Playwright. So we played with the browser flag. So we tested things with Chromium. We tested things with Firefox. We didn't do WebKit because this is Ubuntu. By default, things run in a headless mode. You can run it in a headed mode. Browser channel, basically, it lets you choose which version of a browser you want to test against. We did slow-mo, so that's where we delayed by 2 seconds or 1 second or anything like that. Device, we didn't use this, but you can emulate different devices. The output directory, we just use the default, but you can change where it's saving the traces and whatnot. Then you can save traces, videos, screenshots, full screen screenshots, and you can choose when to save those as well. So you can just say, like, save everything all of the time. Maybe you want to do some extra things for visual diffs. I don't know. Maybe you just want to retain the videos and the pictures and the traces on failure. That also works just fine. So that is a tour of Playwright. Also, the last thing to mention about Playwright is it isn't a Python thing. It has Python bindings. So you can also use it in your JavaScript projects, and I think it has PHP bindings, but I stand to be corrected. So it's quite a versatile tool. That is all from me. You can go over here. All right, so this QR code will give you some links, and then you can watch those other videos if you want to. I'll post some stuff later as well online. And yeah, that's it. So if you have any questions, then go ahead and now is your time. Thank you.
Thank you. This is awesome. It's been a very long time since I last used Selenium, and I can see these kind of frameworks have come a long way. One of the issues we had years ago when we tried this is that a lot of the unit tests generally catch, the functionality bugs and so on. But one thing we couldn't figure out how to test properly was visual differences. So the Chrome driver in general, it finds it by the element index. So even if it's off screen, it'll still click it and say, we're good to go. Does Playwright have any support for spotting visual differences? I did see screenshot functionalities and so on.
Not in the Python bindings, as far as I know, but it might have it in like JavaScript land, because it isn't like Python is its first, like it's not actually a Python library, but I think it has more functionality in different things. I think, yeah, you might be able to just catch the screenshots and then use a completely different tool to do the visual diffs as well.
Oh, just a response to that. It does have JavaScript screenshot comparison, and you can specify the difference, like the percentage at which you want it to complain back to you. So if like you added a different label or a different color, it might not scream, but if you changed it and added a different input or whatever, so like the degree of change that you wanted to complain about, basically.
Thank you, Rudy. Anyone else? Do you guys want to hear why HTMX is the most exciting thing in the world? It's so cool, guys. It's so cool. We've got a few more minutes, so I'm going to tell you why I love this thing so much. Captive audience, yes. So earlier on, I was talking about this versus this. So I actually went through a translation. I had an app that was built like that, and then I heard about HTMX, and I was like, I should rewrite everything. And then I was like, stop, drop, and roll. You never rewrite everything. Like, it's always tempting, but it's generally a bad idea. It was actually a great idea in this case. So I'd heard about HTMX, and I thought it was cool, and I was like, okay, what are the trickiest parts of my application? Let me see if I can quickly HTMX them, because I want to learn this tool. And in an afternoon, I was like, okay, I've done all the hardest parts. This is great. I was working with a team of developers at the time on this thing, and everyone is suffering, because in order to make even the simplest full stack feature, you need to know like all of this stuff and all of this stuff, and it was just a bit of a dog show. And you have to have like this application running and this application running on your computer, and you're constantly context switching, and so you need like not a junior level skill set, like a mid-level skill set, and the ability to context switch between a bunch of different things in order to be productive. So then we switched to this, and then the most junior, most unproductive person on the team could suddenly like do really useful things. Junior web developers struggle to get work, partially because web development has been in like this complexity spiral for quite some time, and HTMX simplifies things in a way that makes everybody productive. So that's why I'm excited about this, and why I find every opportunity I can to tell people about it. I think it's going to be an ecosystem shift, because like suddenly people who were like borderline, like not very useful on the team, like now you can give them like serious stuff to do and they can do it. So yeah, HTMX is freaking great. Are there any more questions or anything? All right. Looks like no. Okay. In that case, have a beautiful day, everybody. If you think of questions later, you can come and chat to me, or hit me up on socials. That's also great. Thanks.
Thanks, Sheena. Thanks, everybody. We're going to do a 15-minute break, and then we'll be back at 2:45 with the closing keynote and a game jam prize giving.